Hi everyone. So this is a revision for classification of linear time invariant systems. So there are 5 classifications, and I guess the first two is a bit uh, you need a bit more work to prove that the system is linear or time invariant, and or both. So, but I guess you guys are now experts since you have done the video presentation. So I hope that is the case. So let's go into the few more examples that I've given as handouts here. Okay. Now the first classification or properties, it's always interchanging in the textbooks. Yeah. Anyway, so for linearity, you can check if a system is linear if the input alpha x1 n, then you will get the output as alpha y1n. Okay, if an input is x1n plus x2n, then the output will be y1n plus y2n. If input is alpha x1n plus beta x2n, then you have alpha y1n and beta y2n. Okay, so in the lecture slide, we just use this particular second test. Okay, right. So that one. So show whether, let's look at an example. Show whether the systems below are linear or not. All right. So what do you need to do? There are several systems here. Okay. So there's a lot of systems there. Okay. So this part, okay, for A, you have a system of yn. You need to put input xn plus x1n plus x2n. Okay, so the output will be y1n yn equals to y1n plus y2n. Right, this one, sorry, I see, man. Okay, so you have to write it like this, for your assessment, because otherwise it will not be clear what you are doing if you don't describe. Let input xn equals to x1n plus x2n. Some of you have asked me whether jalan kerja you betul ke tidak, and I say it's not accurate because the main reason is you don't tell me what you are doing. You simply write xn equals to blah blah blah, all these methods, but I'm not sure whether you know what you are doing or not. So you have to bercerita sikit. So let input xn equals to x1n plus x2n. Then you substitute into the system. So, and then you have, as you expand the persamaan, you get this r2n over r1 plus r2 x1n and x2n. Okay, so you see that this first term is similar to the original or the original system. So, but in terms of x1n, so this is y1n, x2n, this is y2n. Okay, and therefore this system is linear. Okay, for this particular system, so again we repeat the process. Okay, so you need to do a lot of this. I always tell my class that you just make it a habit so that your muscles remember the answers. Okay, so that you repeat this question several times so that not just your brain knows but your muscles also. Right? Okay, so let again, when input xn equals to x1n plus x2n, then output will be so and so. Let input xn equals to this, substitute into the system. Okay, and you see that here, okay, when you substitute here, it's not the same as x1n plus square root of x1n plus square root of x2n. So this system is not linear. Another way that you can do is that you write what is y1n first and what is y2n first, and then use substitute this input. Okay, let's switch to the whiteboard. Okay, so the system was y n equals to xn. Okay, so input if input xn equals to x1n plus x2n, then output is yn equals to y1n plus y2n. Okay, so in this case, okay, you can write as y1n equals to x1n and y2n equals to x2n. Okay, so you can write like this, whichever way that makes you understand your work better. So let xn equals to x1n plus x2n. Okay, substitute into system. Right. Okay, so you have yn equals to x1n plus x2n. All right, so this is definitely not the results that we want. This is not the same as y1n plus y2n. Okay, whatever way that is easier for you to understand the concept of linearity. Okay, let's look at, we'll continue with the next example. Okay, therefore the system is not linear. Okay, here again we substitute substitute the xn with x1n and x2n. Okay, and I think for linearity, this system, the method is very clear. Okay, let's skip to time invariant. Okay, now for time invariant, we need to do two steps only, which is shifted input and shifted output. So shifted input xn minus xn n naught or nd will give a shifted output yn minus n naught, okay, or nd. All right, so for this, for the first system, so when we shift output, okay, we shift all that is n in the system. All that is n in the system, we have to shift. All right, and then so you are shifting in this part, yeah. Okay. So when you shift input, okay, you shift input, you shift only xn. You shift only, when you shift input, you shift only xn. Okay. For shift output, you shift all that is n. Okay, sabar. Okay, so that is so then you compare the two, And if the system is the same, okay, so then the system is time invariant. Means that it does not change with a time variable. Okay, yang ini memang akan berubah because time changes, but there's no explicit change in time. All right, so let's see another a bit. Which one is it? Okay, so this one, okay, for example, yn cos xn. So shifted input, so you shift you shift only xn. Shifted output, you shift everything that is n. Okay, so shift output, shift everything that is n. Shift input, shift only xn. Okay, so let's say lah dekat sini is not cos, this is not cos, this is sine. Janganlah tukar sign ni pula. This is not lah. Okay, sign. Okay, no. I'm not referring to this n, okay? So this is a function, ya. Tak ada kena-mengena with shifting. Alright, so let's see for this one. Okay, for this one, okay, this is xn and cos n. Alright, so shift output means that you shift all that is n. Okay, you shift all that is n. Okay, shift all that is n. Okay, all that's n, you must shift. Okay, all that is n, shift. Okay, shift input, shift x, shift only xn, or adik-beradik dengan dia, maybe there's xn minus 1, you kena shift that one also, right? Okay, so shift all that is n, so means that dekat sini ada berapa n? Xn dengan cos n, so you shift all that is n. Alright, then you shift input, means that you shift only xn, not cos xn, because you are only shifting the input. Okay, so this is where then you compare and you see that if it's not the same, so it's not time invariant. Yeah? Okay, this is another example. So again, okay, for this persamaan, so shift output means that you shift all that is n. Okay, and shift input only shift only xn, atau adik-beradik dengan dia, means that if there are shifted xn already in the system, then you have to shift that also because it is input. Okay, remember xn is input. Right, so shift all that is n, so all that is n you must shift. All that is n you must shift for shift input. Then shift output only xn. Alright, so there you have it. Linearity and time invariant. Okay, so please, when you write your answers, make sure that you have a story to, when you are proving something, you must tell a story. Okay, otherwise, how can a person or the reader understand what you are doing? Okay, so good luck. If you have any questions, please ask. Don't hesitate to ask me. Okay.